This video is on section 11.4, Fundamentals of Probability. Let's look at some definitions to get started. An experiment is any occurrence where the outcome is uncertain, like tossing a coin or maybe rolling a die. A sample space is a set of all possible outcomes. So for that flipping of the coin, our set of outcomes would be heads or tails. That's all that can happen when you flip a coin once. If we're talking about rolling a die, then our sample space would be 1, 2, 3, 4, 5, 6, because those are the things that can happen when you roll one die. The event E is any subset of a sample space. So landing on heads might be the event we're interested in, or landing or rolling a 4 might be the event we're interested in. Theoretical probability applies to situations in which the sample space only contains equally likely outcomes, all of which are known. Likely to flip a heads or a tail. It is equally likely to roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. When you want to compute theoretical probability, it is just a fraction. Now there's two ways to look at this. This is the book's definition. It is the number of outcomes in event E, so n parentheses E, over the total number of possible outcomes, that is n parentheses S, for S standing for sample space. So that is their definition of theoretical probability. What I've always taught is just it's the number of favorable outcomes over the number of possible outcomes, where favorable is the same as the number of event E. I like to think about probability being like a game, and that's why I call it favorable. If you, let's say, we want to know the probability of rolling a 3 on a die, you're going to win if you roll a 3. So you want to think about how many ways are there for you to win over how many total things that can happen when you roll a die. Probabilities can range from 0, which is an impossible event, all the way up to 1, which is a for certain event. So it can go from 0 all the way up to 1. 1 is the same thing as 100%. Right smack in the middle is something that is a 50-50 chance, or 1/2. The probability of flipping and getting ahead is 1/2. There's your 50-50 chance. So we're going to look at a die. It is rolled once. Let's find the probability of rolling a 3. First off, we need to understand what the sample space is. The sample space is the set of all possible outcomes. If you roll one die, one regular 6-sided die, your possibilities are 1, 2, 3, 4, 5, 6. Now, in this case, the favorable is getting a 3. So what is the probability of getting a 3? Well, how many 3s are listed here? 1. How many numbers are listed here? 6. That is your probability of rolling a 3. In my definition, this is favorable over possible. The value that was favorable was this one right here. There was one of those. The possibility is that there are 6 things that can happen. So the probability of an even number, look up here and see which ones are even. 2, 4, 6 are even. That's 3 favorable out of 6. You always want to reduce your fractions. So 3/6 reduces to 1/2. A lot of your scientific calculators will do the reducing for you if you're not very good with fractions. A number less than 5. We need to be careful about that less than. The numbers that are less than 5 are 1, 2, 3, 4. Not 5. 5 is not less than 5. 5 is equal to 5. So there are 4 things that are less than 5 out of that possible number of 6. Reduces to 2/3. We want the probability of a number greater than 7. Do you see any numbers in here greater than 7? Nope, that's our 0. That's our impossible probability. Now we have to discuss cards, and you may not be familiar with what's in a deck of cards, and you need to be familiar to do this homework. So in a deck of cards, there are 4 suits: hearts, diamonds, clubs, and spades. These first 2 are your red cards. The next 2 are your black cards. There are 52 cards total. 26 of them are red, 26 of them are black. The numbers range from ace all the way up to king. Ace, 2, 3, 4, etc. all the way up to king. The jack, the queen, and the king are called picture cards. Sometimes they're called face cards because they have a face on them or they have a picture on them. There are 13 of each suit. These are called suits. Hearts, clubs, diamonds, spades are called suits. There are 13 of each of these. So there's 13 of each number. There are 3 types of picture cards or face cards, Jack, Queen, King. And because there are 4 suits, that really means that there are 12 face cards. So you are dealt 1 card from a standard 52 card deck. Find the probability that you are dealt a king. Now for you guys that know cards, this is a very easy thing to do. If you don't know cards, let's look back. How many kings are there? 1, 2, 3, 4. There are 4 kings listed there out of 52. And 4 over 52 reduces to 1/13. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a heart. So let's look back. Hearts, right here, how many are there? There are 13 of these hearts. So the probability of getting a heart is 13 over 52, which reduces to 1/4. This one, standard 52 card deck, find the probability of being dealt the king of hearts. Well, the king of hearts is right here. That's the only king of hearts. These other are king, but they are not the king of hearts. That means there is specifically 1 card that is the king of hearts out of 52. The only way you will get decent with these card problems is to do enough practice. Keep clicking similar exercise on your homework. Now there's something called the empirical probability, and this applies to situations in which we observe the frequency of an event. The empirical probability of event E is the observed number of times E occurs over the total number of observed occurrences. So if one person is randomly selected from the population described above, find the probability to the nearest hundredth, that's telling us we're going to change it to a decimal, that the person is divorced. Well, let's look in our divorced column. We have 10 divorced males, 14 divorced female, for a total of 24. The total row or column is not always listed. Sometimes you have to do that arithmetic, but they have given us that the total is 24. That is our observed. Go back to the definition. The definition of empirical probability is the observed number of times E, which in this case was divorced, occurs. So it's observed 24 times over the total, and they've got us a full total right here. So it's 24 over 242, and they want us to change that to a decimal, which is, and round it to the hundredths place, which is 0.10. And because we're rounding to the hundredth, you do need to write that 0. Now we want to do what the probability is for female. So for female, we are in this row. Our total number of females is 124, still over 242 because that's the total number of people surveyed, and this will round off to 0.51. So that's what empirical refers to. It just refers to looking at information from probably a survey that is stored in a chart. A fair coin is tossed 3 times in succession. The set of equally likely outcomes is this set right here. And what this stands for, let's say, is getting ahead on the first, then getting ahead on the second, getting ahead on the third. This might stand for you got a tail on the first, then you flipped and got a head, then you flipped and got a tail. So that's what those letters mean. Now, let's find the probability of getting a tail on the second toss. All we care about is what happened on the second toss. So, did I get a tail on the second toss here? No, no, yes, no, yes, no, yes, yes. So that is 4 out of 8, which reduces to 1/2. The next says find the probability of getting at least 1 tail. Now, at least 1 means you could have 1 or 2 or 3. So is there at least 1 tail here? No. Yes, 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 yes. There's 2 tails, but that's okay. That's at least 1. 2 tails here, 2 tails here, and 3 tails here, which gives us 7 out of 8. Find the probability of getting exactly 1 tail. We're only interested in where we have exactly 1 tail. Is there exactly 1 tail here? No. Here, yes. Here, yes. Here, yes. Is there exactly 1 tail here? No, there's 2. How about here? There's 2. Here there's 2, and here there's 3. So the only ones I have marked there are 3. instances where we had exactly one tail. And now we want the probability of getting all 3 heads. Well, there's only one place where it's all 3 heads, and it's right there. That's 1 out of 8. Now, sometimes you're asked to roll 1 die twice, or they may say that they've rolled 2 dice at the same time. It's the same experiment, whether you roll 1 twice or roll 2 at the same time. So we're saying a single die is rolled twice. We have 36 equally likely outcomes shown here, meaning on the first die you got a 1, on the second die you got a 1. This right here might be you got a 3 on the first die, you got a 4 on the second die. And what they're asking us here is find the probability of getting these 2 numbers whose sum is 5, meaning they add up to 5. A nice little thing to know is that your sums on the dice chart occur on the diagonals. So look diagonally, right here is where your sum of 5 occurs. There are 4 of those over 36, which is 1/9. While we have this chart here, let's take a look at some other sums. Let's say we want a sum of 8. Here's your sum of 8 down this diagonal. So when you're asked about sums, you want to look on the diagonal. So a sum of 8, how many are there? 1, 2, 3, 4, 5 out of 36. Sometimes you do probability with spinners. So we're looking at this spinner and we're assuming that it's equally likely that the pointer will land on any of the colored regions. And if it happens to land right on a borderline, we spin again, so we don't count that as happening. So if the spinner is spun once, find the probability that the pointer lands in a blue region. Well, how many blue regions are there? 1, 2. And how many regions total? There are 8, which gives me a 1/4 chance of landing on blue. Find the probability that the spinner lands on a yellow or orange. Well, there aren't any orange, but that's okay because it's or. We're going to win if it lands on yellow or orange. Well, no chance of winning with orange because there aren't any, but we could win if it landed on yellow. How many yellows are there? There are 2 yellows over 8, which is 1/4. So, incidentally, that's telling us that the probability of landing on blue is exactly the same as landing on yellow. Find the probability that the spinner lands on a red and blue. That's not possible. We're spinning it once. There is no way to land on red and blue at the same time, so this is going to be a 0 probability. Here's another one of these chart problems. This says we've got, the table shows the educational attainment of a country's population age 25 and over. Use the data in the table expressed in millions to find the probability that a randomly selected citizen age 25 or over had some college, which would be less than 4 years of college. So look through here. What do we have for, this is less than 4 years of high school, 4 years of high school only, some college, that's the column we want, and we want the total. So there are 45 who had some college only out of a total of 175. Now this time it says express your answer as a simplified fraction. So we're not changing it to a decimal. We need to reduce this fraction. Your scientific calculator will probably reduce for you. But if you don't have a scientific, you must notice that these both end in 5. So I can reduce by 5. 45 divided by 5 is 9. 175 divided by 5 is 35. So it's a 9 in 35 chance that you have found a person who has just some college only.